All right, everybody. Good afternoon or morning, wherever you are. We're going to be rolling through the notes from the section 1.1, the first one we're going to be dealing with on properties of exponents. So you, I know, have seen this before. You've seen it in previous courses. We've even touched on bits and pieces of these. I wanted to do this so you could just get the hang of the procedures as we're going through. And then also, these are going to be really important in another unit when we're going to be dealing with different kinds of exponents you haven't seen before. All right, so first thing I want to talk about is just go through the different properties and say what they are. I won't ever ask you for one of these properties by name, but you do need to be able to use them. So the first one for power, a product of powers, what we need to do with that one is we're going to add our exponents. So over here in our example, that'll be a to the m times a to the n equals a to the m plus n. You're just going to add your exponents. So over here, our first one, it's x to the third times x to the fourth. That's just going to be x to the seventh. Over here, 3 to the fourth times 3 to the fifth would be 3 to the ninth. Over here, don't forget, if you don't see it written, it's got an exponent of 1. So this is going to be x to the ninth. All right, pretty straightforward. Power of a power means you're going to multiply your exponents. All right, so for this one, we would be multiplying m and n. So over here, that's going to be x to the 12th. This would be 3 to the 20th. All right, then for power of a product, you're going to distribute that exponent. So everything inside the parentheses is going to get that exponent. So that's going to be a to the m, b to the n. And then over here, in most of these examples, they already have exponents, so we're combining the distributing with the power of a power we just learned. So for this one, it's going to be x to the 8th and y to the 6th, because I had to multiply each of those exponents by the 2. For number 2, this is going to be 3 to the 3rd and x to the 3rd. Now, eventually, we're going to be going through and actually simplifying that. Instead of writing 3 to the 3rd power, we'll write 27. But for now, we're just going through the rules. All right, and then for number 3, it's going to be 4 squared, and then x to the 6th and y to the 10th. All right, 0 exponent is probably the easiest. Anything with a 0 exponent equals 1. So a to the 0 power is 1. So over here, x to the 0 power is 1. 3x squared y to the 4th to the 0 is 1. 5,432 to the 0 power is 1. All right, so pretty straightforward. We know those. All right, negative exponents are the ones that give people some trouble. So a negative exponent means you need to move it. So if it's a negative exponent just to a variable, you're going to take it and move it to the other part of the fraction. If it's on top, you're going to move it to the bottom of the fraction. If it's on the bottom, you're going to move it to the top. And once you've done that move, you've used up, for lack of a better word, the negative, so you won't write the negative exponent anymore. You'll just write the positive exponent. If there's a negative exponent on the outside of a fraction, outside of the parentheses, that means you're going to flip the entire fraction over. All right, so a to the negative n would be 1 over a to the nth power. So it wasn't a part of a fraction, but we know anything by itself can be written as over 1. And so we took it and we moved it to the bottom. We have to have something on top of the fraction. It can't just be empty. So we use 1 as a placeholder. For this one, the a to the negative n is on the bottom. So we're going to move it to the top. You can write it like this, or you can simplify it to a to the n. They're both correct. All right, so over here on the examples, that would be 1 over x to the 3rd. This would be 1 over 3 to the 2nd. And then this would be the opposite. It would be 2 to the third. All right, quotient of powers is exactly the opposite of product of powers. So when we were multiplying, we added the exponents. So when we're dividing, we're going to subtract the exponents. So this would be a to the m minus n. So over here, that would be x to the 7th. This would be x to the negative 7th. Since it's negative, that means we have to move it. And so that's how it would be written in fully simplified form. All right, last one, power of a quotient is just like power of a power up at the top. You're going to multiply your exponents and you're going to distribute that power. So this is going to be a to the m, and this will be b to the m. And then when we get over here on the side, this is a combination of the two properties. So the 5 needs to go to the x, it also needs to go to the y, but because they both already have exponents, that means we have to multiply. So it's going to be x to the 10th over y to the 15th. Down here it would be 2 to the 3rd over 3 to the 3rd. So the one thing I do want to reiterate that is something that messes people up sometimes is they want to take regular numbers, regular whole numbers, and they want to apply these exponent rules. And with the exception of the power of a power of a quotient, they stay the same. Nothing else is really going to change. It's only the parentheses rules that apply. Otherwise, you're still going to, when you're simplifying these, you're still going to treat your numbers like normal. All right, so what I just gave you is kind of the basics, which again should be super familiar. These are not things that are brand new for anybody. And then on the back side of these notes, the second page, we're going to go through and look at a little more complicated examples where we might have more than one of these rules applying at once. All right, so the two things I want to point out. Your answers should not have negative exponents, and they need to be in simplest form. So no negative exponents means if you have one, you have to move it. And then if it's in simplest form, that means you wouldn't have 2 squared. You would write that as 4. If there's things that you can simplify in a fraction, for example, you want to go ahead and do that. So when they're looking for simplest form, that's what they're looking for. All right, so starting out in number 1, this one's pretty straightforward. It's x to the negative 4th times x to the 6th times x to the 7th. So those are just multiplying. And when we're multiplying our bases and they're all the same, we add our exponents. So negative 4 plus 6 would give us 2. 2 plus 7 would give us 9. So our answer is just x to the 9th. Pretty straightforward. All right, over here we've got a couple things going on. And the nice thing about exponents is you really can change your order. You can attack this in different ways. So you could decide to flip the entire fraction because you've got this negative on the outside. You could definitely do that first. You could also look on the inside and say, oh, hey, I have a negative exponent here. I want to move the x down first. That works as well. You just have to decide how to tackle it and move in. A lot of times I like to start from the outside and work my way in, but your mileage may vary. You do whatever you're comfortable with. So if I'm going to tackle that exponent on the outside, that means I need to flip that entire fraction. So that's going to be y to the 3rd over x to the negative 2. And then I've used up that negative, so now it's just positive 3 on the outside. So from there, I'm using power of a power, or technically power of a quotient for this one. So we're going to do y to the 9th over x to the negative 6th. So I multiplied my exponents and distributed it to the top and the bottom. All right, so now I want to check, am I in simplest form? Yeah, that's simplified. I can't do anything else. But I still have a negative exponent, so I need to move that x. the y doesn't have a negative exponent, so it's not going anywhere. It's going to stay put. So this x to the 6th is going to move up to the top. And so you can write it like this if you want, but this is the more correct simplified form. It would be like that. All right. Jumping down to a little more complicated for number 3. All right, so I want to jump back to that last rule I wrote down below the chart. Treat your whole numbers like normal. So I'm looking at this. I see 16 divided by 2. Just go ahead and do that division. So 16 divided by 2 is going to give us 8. All right, from here, I want to go through and subtract my exponents. So I'm going to subtract for my x's, and then I'm going to subtract for my y's. So when I do x to the 4th and x to the 5th, when I subtract that, that's going to be x to the negative 1. And when I do y to the negative 5th minus y to the negative 5th, when I subtract those negative 5's, I'm going to get y to the 0 power. All right, so, well, what happens when we have a 0? We know that cancels out. That's going to become 1. And then we've got that negative exponent, so that's going to have to move to the bottom. So we're going to end up with 8 over x for that one. All right, jumping over to number 4, I'm going to tackle that parenthesis on top first, and then I'm going to deal with the whole fraction. So tackling that parenthesis, we've got that 2 on the outside, so that means everything on top is going to need to get that. So it's going to be x to the negative 6, y to the 6th, over x to the 5th, y to the 6th. All right, now it's a fraction, so now I can just subtract my exponents. So negative 6 minus 5 is going to give me negative 11. 6 minus 6 is going to give me 0. All right, then dealing with our simplifying, anything to the 0 power goes away, it's 1. And then since that x has a negative exponent, I need to move it and put it down in the denominator. So that's what I end up with, 1 over x to the 11th. All right, last 2 examples. Again, treat your whole numbers like normal. So I've got 7 and negative 3, and they're being multiplied. So I need to just go ahead and multiply those. So that's going to give me negative 21. For the rest of that, it's multiplication, so I'm going to add my exponents. So for the y's, I'm going to do 2 plus negative 4, which is going to give me negative 2. For the z's, I'm going to do 5 plus negative 1, and that's going to give me positive 4. So looking at this, it's pretty simplified. The only thing I have to deal with is that negative exponent. So that's going to have to move to the bottom. And we're going to end up here. Just as a quick reminder, the exponent rule for negatives applies to negative exponents, not negative whole numbers. So that negative 21 doesn't need to move. It's just going to chill. It has nothing to do with it. All right, last one. I'm going to distribute that negative 3 to everything inside that parenthesis. So we're going to get 2 to the negative 3rd, x to the negative 9th, y to the negative 15th. So they're all negative, so they have to move to the bottom. And then the last thing we need to do is simplify that 2 to the 3rd power. So 2 to the 3rd power is 2 times 2 times 2, which gives us 8. So we have 1 over 8 times x to the 9th, y to the 15th. All right, so that's it on all the notes for properties of exponents. Hopefully that was a really quick, easy review for you. If you're struggling a little bit, reach out, email me. But your next step should be to go to the link that says 1.1 practice and go to Delta Math and work through those examples. If you get stuck, send me screenshots, send me questions, and we'll go from there. All right, take care. Thanks, y'all.